YouTube. I got to go over YouTube. So YouTube. So YouTube. Okay, so yes, guys, just getting in the groove for today, and not working. Come on, connect, honey, connect. It seems to not connect. Oh, it is now. Okay, so let's roll the chemistry. Hallelujah. What's up, what's up, what's up, what's up? The world over. Let's start this show, as I say. What do you say? Yeah? So we're looking at polymers. Polymers. And I lost my file. Oh, come on, Bilal. Oh, come on. Okay, so this is a chapter that quite a lot of you struggle with. So I gotta give it my attention. Most people kind of struggle with this. I got to make sure you guys aren't one of them. So we got to make sure we do this well. Yeah? Okay, so, oh yeah, the accent, yeah, let's do this well, yes. I forgot what that was, but let me get back that. Okay, yes, alright, so we gotta do some, yeah, that's the one, let's got to do some chemistry. Yeah, and there's some people on YouTube also watching. So hello, YouTube, what's up, what's up? What's up? Alright, let's begin. Then, unless the question is ever going to be relevant to the exact slide I'm at on YouTube, I shall not be answering those questions. Let's move on. It just distracts me from so much of this. So, let's begin. So, we're going to start the process of understanding polymers, which are a big section of organic chemistry. You got to understand the need for polymers, the uses, and therefore how do we make them. Now, polymers are useful to us because we make so much stuff out of them. We make plastics, we make containers, we make even now conductors. Your cell phones, your TVs are all organic conducting polymers. You must have heard of the term AMOLED, OLEDs. They're organic LEDs, molecules of organic chemistry, polymers that conduct current. You got polymers that make clothes now. Some are natural, some are synthetic. Synthetic means man-made. Some occur naturally like cotton and stuff like that. Some man has made nylon, Kevlar for robes, for stuff. Plastic, polythene bags, polypropylene, PVC pipes. Almost everything that you interact with now is a polymer. Because polymers are generally, most of them are pretty strong, but they are light. My pencil is a polymer. Half of my iPad is a polymer. Semiconductors and polymers, that's all this is all chemistry is about in the real world. Mainly. So material science, polymers, all that stuff. Yeah, so that's why this chapter is important. Now, what we study is how to make them. How do we make polymer? Remember, there's certain properties that polymers tend to have. They tend to generally be solids at RTP. And why the solids at RTP? Because they have generally high melting points and boiling points. And because there are long chain of atoms that in one molecule, long chain, they have very large MRs, very high MRs for that matter, and so yeah, their properties are based on intermolecular forces. What are intermolecular forces? Intermolecular forces like Van der Waals forces. You'll do more of that in A levels, alright? But that's the idea. Now, that's the general idea of polymers. And it's a fascinating chapter because, like I said, it is so useful, so useful. The day you're born, you are using polymers. The diapers that you were born with or you were placed on were polymers, water absorbing polymers, scientifically engineered to extract all the water coming out of your body. And till the day you die, you're going to be interacting, wearing, eating, sleeping with polymers. Oh, yep, it's that freaky, yeah. So they are very, very special to us. I really like them because they are so useful. Yeah. So that's what we're doing with now. Where was I? I was also looking at, to be honest with you, what's it? Yeah, one more thing before I continue. Alright, so polymer, yes, properties of polymers, like I mentioned right earlier. So that's what we have. So you gotta keep that in mind. Any questions so far? Till I open my next thing. Yeah, 1 second. Just 1 second. So for all good. Okay. So. So what we're going to focus on is how we make polymers. Now understand that just as some examples we talked about, if you remember in bonding, we had types of substances. We had ionic structures, we had simple molecular structures, we had metallic structures, and we had macromolecular structures. So polymers are in fact a macromolecular structure. They are giant molecules, which is why they are solid at RTP, and generally they don't conduct current unless we have a special kind of, we make certain polymers that can conduct current. There are some that you can design them to be water absorbing or water soluble, like hair gels and, like I said, diapers. Then there are also natural polymers in your body, starch and amino proteins, fats are natural polymers. Then there were man-made polymers we discussed, like polythene bags, PVC for pipes, the styrofoam cups that you drink out of in coffee shops and wedding halls and stuff like that. And there are PET bottles also, which are like those disposable water bottles. All plastics. Plastics are generally polymers. Then, like I said, parachutes and clothing also. So that's the area of polymers. Now, what we're going to do is we're going to make them. There are two different ways to make polymers. One way, so there are two. So polymers are made by, the process of making polymers is called polymerization. And we make it one of two different ways. We make it either via addition polymerization, and we make it via condensation polymerization. Now, the names are because of the type of reaction that takes place. To make polymers using addition polymerization, you carry out addition reactions. Now, if you remember, addition reactions were with carbon-carbon double bonds. And condensation reactions are where large molecules combine, like acid and alcohol. If you remember, ester formation is a condensation reaction. Acids and alcohols react, so combine, and they give off small molecules. And so that type of reaction produces condensation polymers. This type addition reaction produces addition polymerization polymers, and we shall talk about them now. So I'm going to first talk about addition polymerization, how it's made, the particles that make it. One thing that's common to both is the term polymer. So polymers, both are polymers, and the substances that make them are called monomers. So monomers react to make polymers. Let me in fact change that here. So what's common to both addition and condensation is monomers react to make polymers. So if I remove that, so literally that's what it is. So the molecules that make polymers, because the idea is that small molecules, thousands of them, not even thousands, billions of them, make a large molecule. So when thousands of small molecules make one large molecule, we call that process polymerization. Small molecules making large molecules, polymerization. And small molecules are referred to as monomers. M-O-N-O-M-E-R-S. And the large fellow is called a polymer. Polymer, right? So monomers make polymers. Alright? Vadika, I'm sure I don't know my Latin or Greek. I skipped those classes when I was in school. So, yeah. I'm an uncultured man, yeah. No, just kidding. Just pulling your leg, girl. Okay, I hope that's a girl name because that would be a weird thing to call you if you were a boy, yeah? Alright. I'm on a roll today. I don't know why. Thank you, Anna. Your love on YouTube is appreciated. Hearts from me. Alright, Vadika, she's a girl. Alright, thank you for that clarification. I would have had a troublesome night thinking about that. From I got a girl, boy, girl, whatever. I'm just in a mood right now. Forgive me. Okay, let's move on before somebody says, please let's focus on studying. Okay, so now the first kind of polymerization we're going to focus on, and that generally the easier one, is addition polymerization. And addition polymerization basically is going from monomers. So basically the idea is that it has lots of monomers undergo an addition reaction. So an addition reaction is what they undergo to make a polymer. And note that no small molecule is given off. Okay, nothing is given off. And one property the monomer has to have is the monomers, you realize, to undergo addition reactions have to have carbon, double bond carbon. They have to have this. The same guy, same bond found where? In alkenes. And alkenes are a very popular monomers for polymer, because other compounds can also have a carbon-carbon double bond, but alkenes also have it, a carbon-carbon double bond. You need that in the monomer and those lots of monomers to make a polymer. All right, that process is called addition polymerization. Now I'm going to take the simplest alkene. Now if you remember, the simplest smallest alkene is which one? Is ethene. So I'm going to take that fellow and make polymers out of that. Alright, let me scroll down. Any questions so far about this stuff? Yeah. Mesam, Arisha, Vadika, anybody? I know, yes, you see two screens because I am crazy like that. There are two screens. Okay, you can choose to not see one screen. I don't know. It's just whatever, you know. Please. Please. There you go. Now you see only one screen. Okay. All right. Yo, because Shanaz, that's a question for A2s at all AS level, and I'm teaching an O-level class. And my answer right now is because they don't. Ta-da, ta-da, ta. There are things they need to have to make hydrogen bonds. They don't have. Okay, thank you, Arisha. Awesome, awesome, awesome. I love you too, Mustafa. I think so. Somebody there online. Anyways, getting back here. Where was I? Okay. So, let's take a look at the simplest alkene. Now, C2H4 can be drawn in most places. This is what you would see for C2H4. Now, what I tell my students is, even if you get it drawn like this or any other way, I need you to make it like this. Make the H's bonds perpendicular to the double bond. Make the single bonds on the carbon in the double bonds perpendicular to the double bond. It'll make life easy. And the way polymers are made is that many of these guys, duplicate, 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 come together. Like, okay, hey, I'm here too. Hey, I'm here too. Hey, I'm here too. Wait a minute, do we have more? Maybe so. Wait a minute. So there are many of these. Again, you realize that I'm in a pretty chill mode right now. There are so many. And these 5 represent, let's say, 5,000. Who cares, right? Lots of them. Lots, lots, lots. All right? Now, what happens with these guys? Now, look at my process, okay? Look at the process I'm going to do. Now, it would be nicer if we could have changed the color for this guy to a different color. This fellow, just so that I could talk to you about it. So, what I'm going to do, just to have some fun, I'm going to have alternate red and white alkenes, if you don't mind, okay? So I'm going to take this fellow and move this fellow here. Just because they're all the same thing, guys. But what I've done is, I have taken these guys out and brought these guys in. And let's just put this fellow right there. So now I have this. So I have 6 instead of 5. So imagine these 6 represent tons and tons of alkenes. So what holds true for these 6 holds true for all alkenes. Now what happens is that these fellows, because the idea for a polymer is thousands of these monomers combined. So what I do is I duplicate these first of all. Okay. Duplicate, where is duplicate? Yeah, there you go. No. First I'll take these and I'll just group them and then I'll duplicate them. So now let me show you what happens. So they start off from the top, but when they all react, how do they react? Remember, an addition reaction is what? Addition reaction is when, and I'll scroll up for a second, if you remember, if I scroll back up to the simplest alkene, you remember when these guys would undergo addition reactions, the bond would break. So the bond would break, the double bond, one bond breaks, and you get 2 new bonds, one here, one there. Or here, that's like saying, excuse me, this bond breaking, and this fellow makes new bonds there and there. That's called addition reaction. And that's what starts happening here. So basically, when these all have to combine, what they do is they say, okay, let's break this bond, let's break this bond, this bond, this bond, this bond, this bond. Literally, that's what happens. So bond breaks, bond breaks, bond breaks, bond breaks. But every time you break a bond, okay, every time this bond breaks, this has to bond with something else. So it says, here come, I want a bond. Then this white guy says, I also want a bond. Then this fellow says, I want to bond. So instead of not bonding with anything, what they do is this. So basically, the red carbon ends up bonding to the white carbon. And the white carbon ends up bonding to the next molecules this. But why? Because carbon needs to make 4 bonds. If it breaks a double bond, it needs to make a 4th bond, and that's the 4th bond. That's the 4th bond. This guy has 3 bonds. This guy has 3 bonds. They say, Here, share my electrons. What's a covalent bond? Sharing of electrons. These two are in fact sharing their electrons in a single bond. So they broke this electron and said let's share here. They broke this electrons and they said let's share here. So we got to share here, and they continue to share. They continue this side and they continue that side. That's literally what happens. Now, this process is called polymerization. Okay, this is the most simplest addition polymer you are always going to see. Now, a term for having a carbon-carbon double bond is what? Being unsaturated. And when you make the polymer, you are no longer unsaturated, you are saturated. I hope you guys know that term. Unsaturated, saturated. Unsaturated means carbon-carbon bonds are double. Saturated means all the carbon-carbon bonds are single. In fact, this particular polymer is in fact an alkene now. It's a hydrocarbon and it is saturated. So it's a big mother alkene. This is ethene and this is polyethene. Literally that's the name. So for example, the guy on top is ethene molecules. The guy at the bottom is poly in brackets of what is the monomer. So there are poly of ethene. Ethene is alkene, polyethene is alkane. Alright? Not all polymers are alkanes. The ones made from alkenes through addition polymerization are in fact alkenes. They go from being unsaturated hydrocarbons to being saturated hydrocarbons. Alright? Any questions so far? Hi Nim Nim. Hello Nim Nim. Okay, these are some random people I'm shouting out at YouTube. Oh my god, like, you know, I know, you know, yeah, this is what we have. This is not, what about benzene, Nim Nim? This is not benzene, this is neither O levels or A2, this is O levels. Well, that depends, Ahliya. Are you talking about this session? This session syllabus ends in about 3 weeks. First week of April. Alright guys, I'll move on. Say yeah. So this is what I just showed you. Lots of small ethene molecules break up the double bond and make new bonds. All these red bonds are new. And this is what we call the polymer, polyethene. Now, the monomer doesn't have to be an alkene. It just has to have a carbon-carbon double bond. Yeah? For example, if I had said that, wait, I have this fellow. CF, oh no, let's make it CCl. This is a molecule that has a carbon-carbon double bond. So if you have a molecule that has a carbon-carbon double bond, understand that that molecule can undergo addition polymerization. So here, what I can do is, this molecule can take multiple forms. So basically what I'm saying is, let me remove that first. So this monomer, I want to polymerize. What forms? So what I do is I take a lot of these. Like I said, I take this fellow, then I'll bring my red one. And then I'll just group them together and I'll duplicate, and I make so many of them. And what happens then? How do these polymerize? The idea being, again, I'll take all of this. I have the luxury of duplicating this. So I'll take the whole thing, duplicate this. And when many of these, now I've only shown 6, but again this holds true for many, what happens is the double bond breaks, the double bond breaks, the double bond breaks, the double bond breaks in all of them, and every alternating one can combine, and these continue. So we actually call them continuity bonds. They keep continuing here and here and here and here, blah 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 blah. They keep continuing, and this is the polymer of this fellow. So that's how you make polymers. This one is in fact what we call a PVC. This is actually, this top fellow is chloroethene. So the bottom fellow is polychloroethene. It's a little different from polyethylene because polyethylene all had H's. This has HCl, 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 HCl. Yeah? Any questions about this so far? Yes, Nim. What about A2 Live? A2 Live, I have just said Nim. I keep saying it. I have got like 300 videos for A2s. This is the same shit I want to do live and then recorded. O-levels don't even have much videos. Just watch my videos. There are so many of them. Yes, I will take past paper sessions starting April 1st week. Yes, please can I stop answering questions about anything except for O-levels that I'm teaching right now. It distracts me. I'm in a zone right now. I should stop looking at the chat. I should. Thank you guys for your support and love, but right now I'm focusing on the O-level kids sitting in class right now on Zoom with me. Yeah? Which is live streamed to YouTube. Anyways, moving on. All clear, everybody? ठीक है. Now, if I brought you the first thing back again, basically, just to show you, then we'll go back to this fellow. But let me scroll down to show you the thing I just showed you earlier. So I'm going to zoom out just a little bit. So if you remember this that we saw, right? This thing that we just saw earlier. This was multiple ethenes making up this polymer. Now, what you start realizing is a few things, first of all. This, because what happened to each individual unit? Each individual unit went from being, let's look at the white one. It went from CH2, CH2 to still being CH2, CH2, but those double bonds became a single bond and you got these two new red bonds. So for example, the white fellow became this. It went from being CH2, CH2 double bond to being CH. So each monomer, so what's happening to each monomer? This is really what's happening to each monomer. It goes from this to this. But now it has these two bonds sticking out. Think about this guy. Look at this fellow and look at this guy. This was the monomer and this is the polymer. The way we draw this is that we had n number. Now why we chose n? It was any variable that represents a large number. That says 1,000. And then instead of having 1,000 polymers, you have one long chain. It just happens to be repeating n times. If you notice here, you got 1, 2, 3, 4, 5, 6. So we're repeating them 1, 2, 3, 4, 5, 6 times. So 6 would have made this repeat 6 times. This is how we write the polymer. Literally. This is how I would like you to write the polymer. Alright? The same thing would have happened with this fellow right here. You see this guy? So here, let me take the first one, duplicate the first fellow. The white fellow. What happened to that fellow? The white fellow literally just became this guy. You see that? In fact, let me just bring that fellow right here. You see? I'll take that fellow, I'll duplicate that. Same guy. I'm in fact taking out away from the like that. See that fellow? Taking out, putting it right here. And between them, it has these blue bonds with the red guy, which is the exact same thing. Then the white guy, then the red guy, exact same thing again and again. So what we have here is that you write them as n of these has n repeats of this 2 carbon unit. You see that? So this fellow, if you have 6 of them, will repeat 6 times. If you have 50 of them, will repeat this 50 times. Alright? So this is how we write the monomer. This is the polymer ka simplest unit, n times. This is the equation that represents what just happened from here to here. Alright? Sorry guys, I don't know what happened here. Yeah. In fact, the trick is this, that regardless of this Cl or H's or whatever else, what you do is you decide, you first draw your monomer in this fashion. Whatever it is, anywhere, it doesn't matter as long as it's the carbon-carbon double bond in the center. And this breaks up to become like this. So what you want to know is that, okay, so n number of these guys makes these continuity bonds and n times that fellow. So if there were 4 H's, 4 H's. If there was HHHCl, HHHCl. If it was HHHF, HHHF. It was FFFFFFFF. And why don't I just say FFFF? Because there is a molecule called FFFF. That's another polymer that we have. So let me show you the 3 that we just talked about, right? The 2 that I definitely just talked about, the last 2. I need some space. Let me show them to you. All right? But any questions before I do show you that? My voice is lagging. That's the mystery that they don't teach you. You think they teach you, but the idea is that in a billion bonds, the n bonds don't matter. But because if we were to tell you, you would focus on the n bonds. That's why we don't want to tell you. Right? We don't want to tell you. We don't. Because then that's all you will focus on. Yeah. They can't something cute. I could tell you, but I'll have to kill you then. It's a secret. We scientists keep. We don't want people to know. We don't want the normal man to know. Come on. I'm just kidding. The last end guys have to have some weird double bond to finish the molecule. Or get hydrogen from somewhere. From anywhere, hydrogens. Or the last carbon makes some form of weird double bond. Or a double bond in fact. I'm kicking out hydrogens. Okay? Does that answer your whatever you call it? Yeah. Ek to linen fangs. Why the hell are you in 2 places? You can't see me just need because I pulled my camera off. And the reason for that is because there are too many molecules. And then some of them will hide behind my face. My beautiful face is not visible. And everybody's wondering what's going on. What's going on? We don't even have regulars today. Ramesh isn't here. Hanan isn't here. I don't know what's wrong with peeps. They don't show up. And these things take so much energy out of me. I'm here, I'm everywhere. Hey Sunny, are you the village? कहते ना उर्दू में आप अपने गांव की गाय हैं? Are you the? I shouldn't even say. Anyways, moving along. Any questions about this, guys? Are we all good? So, these guys that you saw, the three at least that you've seen so far are polyethylene, polypropylene, and PVC. No, polyethylene and so on. Now, what I'm going to show you is this fellow right here. Look at this fellow. These are basically two examples. I just showed you this one. Remember CH2, CHCl, that's the monomer. It's called chloroethene, ethene, and that's the polymer, polychloroethene. The old name for this guy is PVC. Pipes are made of this polymer. Pipes are made of this polymer. And this is the equation. N of CH, they've made it at an angle. You can make them vertical straight or an angle, up to you. It doesn't matter. N stands for lots of them. And it is like this. So N of lots of the monomer makes the continuity bonds, breaks the middle bond and gets to the N. Here is a very popular molecule used to line pans. So PVC is good for pipes, it's hard plastic. And this is for non-stick pans. This polymer is used for non-stick pans. What is this polymer? It has the monomer C with two F's, upar niche, two F's, upar niche. So the monomer is C double bond F on top, F at the bottom, F on top, F at the bottom. And N of this combined to make CFFFFF. Yeah, that fellow. And what you do is you put the four F's, 1, 2, 3, 4, the continuity bonds, square brackets or curly brackets, whichever you like, and N. And that's your equation for the polymer, and it's CF, 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 multiplying multiple times. That's part of the polymer molecule. That's the equation. Alright? So these are the three of the basic ones you need to know. Ethene, polyethene, chloroethene, polychloroethene. This is called tetrafluoroethene because there are four F's. And this fellow is called polytetrafluoroethene, shorthanded as PTFE, standing for polytetrafluoroethene. Its street name, or the name given by a company that made this, is called Teflon. Teflon is the name given to this molecule. And yeah, if you ever want to watch a movie about this molecule, it's called Dark Waters. You should watch that. Beautiful movie. I'm going to continue. Alright? Any questions about this? This. Okay. Now, moving along, remember, I've said the whole goal is this. Whatever alkene you're given or carbon-carbon double bond you're given, you've got to be able to polymerize like this. They take the double bond, make continuity bonds. So these guys that I'm highlighting are your continuity bonds because of the double bond breaking up. The guys on top at the bottom remain as is. We don't care who they are. There could be even more carbon atoms. We don't care. But every monomer has to first be drawn like this, and then. So when they say, how about you polymerize ethene, propene, sorry. And that's what I want to show you using this method. So I want to polymerize propene, which is C3H6. Now how would I do that? It's an alkene. How do you know it's an alkene? Because this is the structure of propene right here. So when I look at this fellow, it has a carbon-carbon double bond. Because if something has a carbon-carbon double bonds, it can become an addition polymer. So let's polymerize this fellow. So I'm gonna go on top, use this fellow again, bring that molecule down, make this a little smaller, so that the goal is this. The goal is to make this molecule first look like this and polymerize like this. So I tell my kids this. First of all, make this molecule fit this structure, where you take carbon, and I'll draw it right on the right, carbon-carbon double bond, bond up, bond down, bond down. So if I look at this, and if I have C double bond C, the right guy is H and H. So that means the right guy on top and at the bottom is H and H. And this fellow right here that I'm pointing to, if you see, is this fellow right here. Same guy here, 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 here. So it's an H and C with 3 H's. So you will actually have to end up drawing it like this. CH, CH3, CH2. Now this is in this version. And now I'm going to take this guy. Now I've got to make n versions of this. You see that? So I'll take n amount of that, break the double bond, and I'll just duplicate that first. And then what do? I break the double bond. Yeah. Then what do I do to this fellow? What do I do to this fellow? What I do is I open up make the continuity bonds and n times this. Now you might say, well, what's really happening? What's really happening is n's version of this fellow, like duplicate, duplicate. Let's take 1, 2, 3. Let's just take 4, huh? So 4 of these guys are like just as n. What's happening to them? They are polymerizing to make a polymer. So I'll take the repeat unit guy, duplicate, duplicate, duplicate. So that fellow becomes this, that fellow becomes this, that becomes this, and one more I need, duplicate. So here I've taken these guys and I've opened the double bond. And I would like some breathing space, so I might just do that right now. But then zoom out just a little bit. So the goal was to make the polymer. So the double bonds broke, and now you get your continuity bonds. Tuck, 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 tuck. That's the stuff you have to play with. And there. So this is the polymer. The beauty is that even though the monomer had 3 carbon atoms, the polymer's center chain, if you notice, the center chain has only 2 carbons from the monomer. The third one is now what we call a branch. Even though when I gave you the question, the polymer had 3 carbons, the monomer. The problem is the main chain of the polymer would only have 2 of those carbons, the ones in the carbon-carbon double bond. The third fellow will just be written separately. Alright? It becomes a branch. This is the biggest mistake I have kids making when you come to A levels having done this. I'll show you some more examples. Yes. Rida, the polymer is just poly of the monomer. That's what it is. So whatever the name of the monomer, the polymer is poly of that. So if the monomer is 5, the polymer is poly 5. If I'm just being that stupid. Okay, whatever the name of the monomer, the polymer is poly that. So here, for example, the monomer is propene. Now propene, I have made this like this in this case. It's CH2 double bond CH. I'm using the same exact example again just to highlight that. This is propene drawn now like this. It doesn't matter now. As long as the carbon-carbon double bond and everything else is on the tops of the bottom bonds. The goal is to open it up like this, remember. So you put them like that and then they break up and that becomes the continuity bond. It doesn't just happen with this fellow. There are any more that have more carbon atoms. I'll show you other examples also. Here the carbon is part of the main chain, but it becomes a branch. Another example is, if you remember polystyrene cups, the thermopole cups or all that you drink coffee out of. They are actually of a molecule CH2 double bond CH, then a large enough compound of 6 more carbons section. So when you do this, what you do is just make it like this. So C6H5 and H. All you gotta do is make it like that fellow. Yeah. And so literally duplicate, let's do 4 of them because I like showing off that I have this nice little tool of duplication. So I have these 4 guys that I can just duplicate, group and then duplicate. So no matter what chain, how much carbons you have in the chain, what's going to happen is that fellow is no longer part of the carbon in the double bond, it's somewhere else, right? So you put it on top or at the bottom. Once you do that, you break the double bonds and you put continuity bonds, top, and top. That's it. So this fellow, so for this fellow, this is the monomer, and I'm just duplicating the guys from the bottom so that I have to draw them. So N version of this becomes N times that. Now you don't need to know this polymer. If you're given the monomer, only then you can draw the polymer. That's what they want. They give you monomer like this, you draw like this. All right? Okay? Sorry, that was earlier. Can I continue? Any questions, guys? Hello? Yeah? Any questions? What up, yo? Ultra Gamer, that's for later. Not yet? Alright. Now, the one more thing you need to learn about this. In addition to the monomer, the polymer, which is an N, is the most basic repeat unit. The idea of repeat units. So the repeat unit of a polymer is just the smallest thing that repeats itself. So literally whatever is inside the brackets is a repeat unit. Here this fellow is called a repeat unit that I'm highlighting. Or like imagine this set of atoms repeat themselves again and again and again. So all these 4 different highlighted sets of atoms are what we call repeat unit. You are given this, you gotta look at it and find a repeat unit. Yeah, that's what you gotta do. You gotta look at polymers. Like so, when you go back up on top, let's find right here. See, one of the examples we did earlier. What's a repeat unit here? A repeat unit is the smallest unit that repeats itself. So this fellow that I've circled is repeating here, here, and here. So if you're asked, you literally just draw this as a repeat unit, CH. Because you will be asked to draw the repeat unit of a polymer if you're given the, and when you look at the repeat unit, you can also therefore even make the monomer from the polymer. You look at this, you look at the repeat unit, and then the bonds that are continuity bonds have to be undone, and this bond made a double bond to get the monomer. So sometimes you're given polymers to make the monomers. For example, here, if I focus on these guys. So here, one repeat unit, then the next repeat unit, then the next repeat unit, one repeat unit, then the next repeat unit. Now obviously, this got 2, 2, 2, 2. This is a half a repeat unit. So it's not really a repeat unit. So all these that I'm highlighting are repeat units. In this case, in this case, in this case, this is a repeat unit. So you can look at repeat units and therefore make the monomer. For example, I'll give you another polymer that you haven't seen. And let's see if you can figure out the repeat units and then the, the polymer. So I'm going to zoom out and go back here and show that to you. Here you go. So let's take this polymer. Sorry, I'm going to make this smaller. So this is the polymer, a section of the polymer. How does one find a repeat unit in this case? Literally, in addition polymer, every 2 carbons are a repeat unit. So these 2 carbons are a repeat unit. So this fellow is quite visibly repeating itself here also and here also. Therefore, that is my 1 unit repeat unit. Then you might wonder, therefore, then what's a monomer? So first, let's draw the repeat unit first. So let me paste that for you. Now this becomes a repeat unit, if you notice. It's this guy taken in a singular unit. So this is a repeat unit. You can even make the polymer out of this, or the monomer. So if they say draw the formula of the polymer, so this is a section. So on top is a section of the polymer. Then you got a repeat unit, which is a single unit. Then they ask you to make the polymer. So you just take the repeat unit and put N around it. It's called the formula of the polymer. And then if they want the monomer, take the repeat unit and remove the continuity bonds and make a double bond right there. So when you do that, what do you get? Let me show that to you also. Can you figure out the monomer then? This way. I hope you figured that part out. That would be a waste of an hour if you couldn't do this. Yeah? Alright. This ends how to draw addition polymers. Alright? Yeah? All good? Okay? Guys, are we done? I'm done. Please. Yes. I got another class. Yes, after polymerization, we'll start electrolysis. Yes. Okay? Goodbye, everybody. Have a nice day. I had a good time. Yeah? Thank you very much. Bye-bye.